Today's paper is mrcnn, object detection via a multi-region and semantic segmentation-aware CNN model. In this model, selective search is still used to make region proposals. However, instead of using one box for training, multiple regions are created for each box proposal. Also, to boost the performance of the model, segmentation-aware CNN is used together with localization techniques. Here's the figure showing the architecture of the mrcnn model. Input image first goes through the activation map module and outputs the activation maps. Then region proposals or bounding box candidates are generated using selective search. And for each bounding box candidate, a set of n regions are generated. This will be discussed later in the video, and the name of the model mrcnn comes from the use of multiple regions per bounding box. ROI pooling is performed on each region, and this region is fed into the fully connected layers, and this is shown at each region adaptation module. Finally, all the outputs from each region adaptation module are concatenated together to be used to represent the bounding box. Different region shapes are used to focus on different regions of an object. The goal first is to force the network to capture various complementary aspects of the object appearance, leading to a much richer and more robust object representation. And another goal is to make the resulting representation more sensitive to inaccurate localization, which is also crucial for object detection. Two types of region shapes are used in the paper: rectangles and rectangular rings. First, A in the figure shows the original box proposal obtained by selective search algorithm. And from B to E shows the half parts obtained on each side of the box. Half regions of the objects are used to guide the network to learn robust representation of the object. Central region in F and G is also used. These regions are used to train the network to capture the pure appearance characteristics of the character's center part of an object. The border region, shown in H and I, are also used. These are in the shape of rectangular rings. The use of this region lets the network focus on the joint appearance of characteristics on both sides of the object borders, also aiming to make the representation more sensitive to inaccurate localization. Lastly, contextual region shown in J is utilized. When using this region, the network is driven to focus on the contextual appearance that surrounds an object, such as the appearance of its background or other objects next to it. Because there is a close connection between segmentation and detection, segmentation cues are used to help localization. As shown in the figure, segmentation-aware CNN is further used, and for this, the two new modules are added: activation maps for semantic segmentation-aware features, and region adaptation module for semantic segmentation-aware features. The fully convolutional network, also known as FCN, is used for the semantic segmentation activation maps module. The features from the new module are used together in the concatenation layer, which is used for the object representation. Note that while training the segmentation branch, weekly supervision is used, meaning, as shown in the figure, bounding box ground truth region is masked to indicate that the region should be activated. The object of interest and this mask is not well aligned, but the use of this weak label still allows the network to find salient regions of the object. In order to make well-localized candidate boxes with high confidence, the authors propose three main components. These are CNN region adaptation module for bounding box regression, iterative localization, and bounding box voting. The new CNN region adaptation module for bounding box regression is composed of 2 fully connected layers and 1 prediction layer. And this works on top of the activation maps produced by the multi-region CNN model. In summary, the localization scheme in the paper starts from the selective search proposals and works by iteratively scoring them and refining their coordinates. At step 1, initial bounding boxes are obtained from the selective search algorithm. At this stage, boxes with low scores are rejected. Then, at step 2, boxes from step 1 are regressed further by performing CNN-based bounding box regression. And at step 3, the same operation is performed again, regressing boxes at step 2 to the CNN regression model. At step 4, the boxes from step 2 and 3 are merged together to form a big candidate of bounding boxes. Lastly, at step 5, non-maximum suppression is applied to the grouped boxes, and box voting is applied to obtain final detection boxes. As shown in the last image at the bottom, ground truth boxes are marked green. The blue boxes are the true positive results, and red box represents a false positive box. Now, the top table shows the performance of mrcnn model on PASCAL 2007 test set. When using only single original box, the mean average precision score is 61.7, and when using multi-region technique, the score goes up to 66.2. Now, when using mrcnn with scnn, the MAP score goes up once again to 67.5. Lastly, when localization technique is applied, the MAP score reaches 74.9%, outperforming the rCNN model. The bottom table shows the performance of the model on VOC 2012 dataset. And here too, the model outperforms other models when using mrCNN with scnn and localization techniques. Lastly, here are some qualitative results presented in the paper. The ground truth boxes are presented in green, and true positive predictions are presented in blue. Link to the paper and some useful resources will be provided in the description. That's all for today, and I'll see you next time with a new paper.